Hello, Professor. My name is Colin. My ID 011414184997. These are my assignment ones. Um, so these are the library, TensorFlow, Matplotlib, TensorFlow that I imported. Um, I have already ran this question, so probably gonna walk through, explain each of these question. Um, so the first thing, of course, I have to import the library for data science, right? So the first thing I have to train them. So the data set has 60,000 training and 10,000 uh, images. Each has a 28x20, right? So the label are 1D arrays of 60,000 and 10,000 entries, right? So here are the train labels. As you can see here, train image, train labels, and I actually have run it. So it's actually showing here. So so as you can see here, the trend label has like 10,000. So I have put actually trend label. I actually check the lane here. As you can see, the lane of trend label is 60,000. Test label 10,000 label, and then I slicing it, and it show you the first trend label, an array of 10 items, and the first 10 test labels here. Um, for next question, which is question 4, so I actually need to change the image, right? I have to 5 pixel value, right? Range from so these are 5 pixel value. I have actually run it, so it typically range from 0 to 255 after normalization, because I dividing by 255, value become, so typically the value range between 0 and 1. The plotted image, right, is a, so here you can see the plot train image, um, it, train image index 5. So this is look like a shirt. So it has a scale of I think this is x horizontal and y vertical. Um, uh, as you can see here, so yeah, this is a label. So the for the question 6, so for the question 6, the class name contain pretty much the information about the dress, like the t-shirt, the trouser, a bunch of things. Like I said, the plot image is contain the class name, So this one is typically, I think it's I'm not sure what it's called, like a t-shirt tops, right? I think so. So typically like that. So so technically after I plotted the image, so the next thing we have to do is actually to test it. No, to digital content testing. Yeah, exactly. The next thing we have to test it. I need to test image 500 pixels, right? So yeah, as you can see here, 500 pixels, uh, because I mean I have to test 5 pixel data because some data looks similar, right? Because some image they look similar, so the plot actually it's really still the same thing. The content, the test image 500 is actually, as you can see here, this is the test image index 500. Yeah, the blog show, I'm not sure what is it exactly. I think this one is a t-shirt as well. So it's matching. I think it's matching the label values. So for the question 10, I imported the model and the layer from TensorFlow library. So I actually imported it from the tops. So as you can see here, 10 import model and layer. So I typically just uncomment it out here. So question 11, I simply just create a network, use a sequential, right? Because so the sequential model, first I flatten 28 x 28 images into a neuron and normalize the information, the data, right? And then the output layer uses the softmax to produce a probability for the 10 classes. Well, typically, why use the softmax? Well, softmax converts logics to probabilities, ensuring they sum to ones. Well, it's ideal for multi-class classification, right? So as you can see, the hidden layer. So I typically put so there are actually two hidden layer, right? 250, 212, no 512 and 12A, right? With ReLU activation at non-linearity. So the race the output will typically produce probability for the 10 classes, right? So as you can see here, there's 10 classes, softmax, right? Um, and then what I have to do, of course, I have to compile it, right? I use Atom Optimizer. So the Atom Optimizer adapt learning rate dynamically sparse uh, categorical cross-trophy work with integer labels, right? So with losses and metric accuracy, right? And then I need to train the model. I train image, train label. So if you look at this one, I use epoch over 10 epoch training accuracy rose steadily, right? Validation accuracy suggesting possible overfitting, right? So then I train it, and then when as you can see, when I run it, the accuracy is actually increasing from I think so from 0.7. So typically it's about 70% and up until like almost 100%. No, till like 91%. I mean 91% for a large data set like that, which means it's pretty good, right? And then I recompile with the option B. So it's asking it require one hot labels. So this one is typically good as well. Um, I optimize for optimizer. I use RMS props, and then I test it again with epoch 10. So I get the accuracy increasing again from 91% to 92%, which mean it's increasing by a bit, not too much. For the evaluation, for the test loss and test accuracy, I the final result is actually 88%. Uh, so on recap, so this assignment actually highlight how the data set complexity impact model performance. Um, I think for the large data set with 88% accuracy for evaluation, I think it's pretty good. For the I mean for the beginning of a large data set for me to be able to train the model like this. So I think it's actually good. Thank you for watching my video.